Okay, I'm going to go over 62. For those who already found no difficulty with the posted notes, you can just move ahead to the homework and assignment. But I want to record this for those who had difficulty because there wasn't audio. So I'm going over number one. I'm going to follow along with the notes, so it's virtually identical, but I'll explain it to you. This should be recording good. Okay, so this is page 62. 1A. How come that's not? Just trying to frame it. Okay. Not very clear. You got the notes, so if it's a little unclear on the board, you'll have to match it with the notes. Okay, let's go over, make sure you have 62 out in your workbook. It says given two small chocolate candies, big M, small m, what's going to happen to the force between them? So I called this the original force. Fg is equal to GMM over R squared. I could have gotten more complicated and written another subscript. I could have said, oh, it's the original. I could have done it that way. That just overcomplicates it. That is the original. That expression stands for the original force, whatever number that is. Okay? Where R is the original distance. We're going to double the distance. Okay, so the new distance is twice that. I'm going to write down the expression for the new. I'll use the subscript new here to distinguish it from the original. That's original, that's new. The expression on the right has to be slightly different. Why? Because the new one has a distance that's 2r, not r. So instead of r here, I'm going to put 2r. Okay? Why it's a new force? It's a new force because it's a new distance, twice the old distance. The old distance is represented by r. Okay, so you take what's in brackets. Mathematically, when you square whatever's in brackets, that means you square each factor. So you're going to square the 2 and the r. Okay? What am I looking for? I'm looking for an expression that looks like this because this is my original force. I'm looking for that wherever I can find that. And it's in there. You can see it's right here. That's my old or original force. Some number represents some number, 10, 20, whatever it is. I'm going to simplify this. This is 2 squared, which is 4. Mathematically, you can just take the whole thing out and put 1 over 4. Times this. What is this? This is just the original force. So what do I get? The new force is 1/4 of the old force. A lot less. It's 1/4 of the original. Okay? It's not as clear or as in focus as I'd like, but you'll get it because you piece it together with the notes. It's identical. Yep. Yeah. This is, I mean, if you want to go an extra step, you could do this. If this helps. This is just 2 squared is 4. And then mathematically, I can bring that 4 out. It stays in the denominator. There is a 1 here, right? There's an actual 1 here. It exists, just not shown. I can bring it out in front more clearly. So you can do that mathematically. That make sense? I'm going to erase it because I have to stick, if I'm going to record it, I've got to stick with just this part of the board. So move on. B. Yep. You can't. Okay, B is tripled. So this is the original. This doesn't change. This is my original expression. But instead of doubling the distance, now I triple it. So the new distance is 3r. This is the new distance. Should be in frame, yeah. Okay, so what's the new force? Yeah, I'm just gonna, when I ask questions at this point, it's just kind of to myself. But the new force is GM M over, not R anymore. The new distance is 3 times the original. So it's 3R. Square it. Don't forget to square it. Square the whole thing, not just the R. New distance is 3 times the original R. So what's this? It's very similar to what we did before. Squaring whatever's in brackets means square each factor. Square the 3, you get 3 squared. Square the R, you get R squared. I'm looking for this. This is always the secret. Look for that expression because that's the original force. What's the 3 squared here? It's just 9. 3 squared is 9. And there is a 1 on top. So it is 1 over 9. I can bring the whole thing out to make it more clear. The 1 is hidden, but it's there. So I guess you can't see over that. So I'll put it to the side here. It's 1 over 9. Over this, which I'm going to circle. What is that? My original expression. I'm going to erase. I'll put it. Can I put it in there? Yeah. So this is just 1/9. 1/9 of what? FG. What's FG? What I call the original force. But what am I saying? Similar to what I said before. The new force goes here on the left. The new force is 1/9 of the original. New force is less. How much less? 1/9 of the original. Divide the original by 9. That makes sense, right? The farther and farther these two objects are, what happens to the force between them? Yeah. That's what you expect. Okay. This is a little harder. C, half the distance. Everyone got this? It's all in the notes anyways. C. Again, this is the original. Original force, whatever that is. It is some number. It could be like 10. That's the value, let's say, of the original force, 10 newtons. What's the new force? Well, we have to figure out what factor we multiply the original force by. Do the same thing as we did before. The new distance is the original. The new distance, we're told, is a half the original, 1/2 part. The distance is now reduced. And A and B was increased. Now it's reduced to half the size. The objects are pushed closer together. What do you think is going to happen to the force? Increase or decrease? Increase, because they're closer together. More of a pull. Okay, so FG new. Instead of R, I'm going to insert the new distance, 1/2 R. Don't forget to square the whole thing, not just the R. square each of the factors inside, square the half, you get a quarter. Square the r, you get r squared. That's my original. We'll come back to that. That's my original force there. Okay, so what do you have? You have, there is a 1 in front. You have 1 divided by 1/4. Okay, I want to do that over here. Do I have enough room? I'll do it here because I can capture it. So whenever you divide by a fraction, here's the rule of math. If you divide by a fraction, it's the same thing as multiplying by. Divided by 1/4. I'll rewrite it so it's more clear. This is 1 over. Yeah, 1 over 1/4 is 4. Put a 4 in front. What do we call this here? Does that represent? Yeah, the original force. So the new is greater than the old, which we expected by how much? 4 times. So if the old or the original was 10, the new is going to be 40. D. D is very similar, except instead of a half, you've got a third. So I'm going to cheat a little. What do you think I can replace this 2 with? 3. Okay, when you square the 1/3, you get 1 over 9. 1 over 9. 1 over 9. 1 over 1 over 9 is the same thing as 9. New force is 9 times the old. Nine times the old. Okay. See if I got time. I've got 10 minutes. Should be able to do it. Okay, I'm going to go over 2A. Everyone got this? To A, just read it. Says 100-kilogram person. Okay, what's the force between a 100-kilogram person and the Earth? You got 2 masses. You got the mass of the person, that's the small m, and the mass of the Earth, which is 5.98 times 10 to the 24. Okay, so what's that force? And where are we calculating it? We're calculating it at the surface. So we're told the radius is 6.38 million. You want to put RE here. RE represents the radius of the Earth. The distance to the surface is the same as the radius of the Earth. Big G is 6.67. Big M represents the Earth. Small m represents the person, 100, has to be in kilograms. RE, radius of the Earth. Don't forget to square it. Okay, works out to be 980. I'm just calculating the absolute value. In the notes, I put negative to indicate it's down, acting towards the center of the Earth. It acts down. Don't forget, the unit's newtons. Always include a unit. It's the same thing as any force, newtons. B, I wish I could compare it. I just don't have the room, so I'm going to have to erase it. Everyone got that? Got to erase. Well, it's in the notes anyways, so I'm just repeating that. So B involves the moon instead of the Earth. You know what? I can actually keep this number in your, if you can remember, try to remember, 980. Okay, that's what the value is for the Earth. Now we're going to calculate for the moon. Moon should be less because the moon has less pull. I'm going to change a few numbers. I'm going to change the number on top. This becomes Rm, radius of the moon. This is no longer the mass of the Earth. It's the mass of the moon, which is 7.35, 10 to 22. The mass of the person remains the same. The radius of the moon is less. It's 1.74 instead of 6.38. Okay, that's what's different. What makes up, even though it's a smaller radius, which should give us a bigger value, what more than makes up for that is the mass of the moon. It's far less than the Earth. It's like 100 times less at least. Right, so that gives us a value of 1.6. 1.6 or 1.62. 2 or 3 sig figs is fine. So remember I told you to keep that number in your head, 980. That's the weight on the Earth. On the moon, it's 160, which you'd expect. Your weight can change depending upon the planet or moon. On the Earth, it's more because there's more of a pull, 980 compared to 160. Okay, 2 golf balls. 2 small little golf balls. I'm going to erase this because I need to show you a couple things. Everyone got it? I'm running out of time here. I can do it. C. We have the mass. Let's do the following. Let's do a conversion. We have to have our mass in kilograms. So 46 grams divided by 1,000. That gives us kilograms. R. We need meters, not centimeters. Divide by 100. That's the units we use, kilograms and meters. Now we can do the calculation. I'm just going to put small m times small m because they're both the same mass, both small. What's m times n? How can you simplify that expression? M squared. I'm going to rate that and just put m squared. That helps us save a little time here. So it's g m squared. Times m times r is 1.4 times 10 negative 11. Small. 1.4 times 10 to the, look at this exponent. Don't forget the unit. Look at it. When it's negative, that means you're dividing. You're taking this number, 1.4 times 10 to the 11. You're dividing 1 by 1.4 times 10 to the 11, which is, You're dividing 1 by a really big number. What do you get in terms of it? What's the output? Is it a small number or a large number? Yeah, so this represents a really small number, which is consistent with what you know. Do you feel a force of gravity between you and the chair or you and your computer? Have you ever felt that? No, because it is there. There's even a force of gravity between you and the other people in the room, but you don't feel it because the exponent is so negative. It's a very small number. Okay? One last point. I did not get, am I going to get to friction? I didn't get to the friction part, so I will record that during my spare. I'll post it as 2 videos. Capiche? Okay, so I'll do that later. But that at least gives you part of it.